everything is working as it should. Looks good. Is working as it should. All right, so we are ready to go. Go ahead and sign into my accounts. Hello everybody and welcome in. So we got this going here. All right, so that's pulled up, ready to go over there. Pull up my account over here. A little bit. Let's give it a chance. Okay, disconnected, reconnecting. Let's see, hopefully we're back on here. Dropped frames, looks like we're back now. Let's go ahead and check and see. Dropped frames, looks like we're back now. Okay, so the sound looks like it's working now, which is great. I'll just keep an eye on that, make sure that it's working as it should. So anyway, what we're going to do is this is a study stream, and it is the process. It's showing multiple learning avenues at the same time. So it's a review of mathematics. That's why the subject material is Augustus De Morgan's the Elements of Arithmetic, which is essentially also a little bit of a foray into algebra as well. It's a little bit of pre-algebra going on as well. And the Copywork itself, although I don't advocate using Copywork as an effective study strategy. It's much better to practice elaboration, proper note-taking, so on and so forth. It is still useful in my particular avenue of learning, because I am learning how to use a system of writing called Gregg Anniversary Shorthand. This is a type of phonetic writing in which you are recording the sounds of speech. And it looks like we lost connection again. Bother. Dropped frames. Disconnecting, reconnecting. Oy, I tell you. Let it do its thing. We back on? Dropped frames. Looks like we're back on now. Crazy. Okay. Well, looks like we're back now. So the purpose here is to practice these different aspects of learning. So, like I said, it's a math review, and it's also giving me the chance to essentially to do a little bit of copy work, but not just regular old longhand style copy work. It's Gregg Anniversary copy work. So that's essentially the stream. It's also giving me the opportunity to practice presenting on screen. So like I said, it's serving a multitude of purposes. So without further ado, let's go ahead and get into it. If you're interested in any of the links, they are down below. You can take a look at the book if you want. There's a PDF version, a free PDF. There's a copy to the Gregg Anniversary Shorthand website that I use. Some other resources if you're interested in supporting, or like if you like this sort of content. I'm not sure why you would, but if you are, if you're crazy like me and you think this is kind of an interesting avenue of study and possibly a good tool to bring back into circulation, I've got links down there to show support. So anyway, without further ado, let's get going. Okay, I've got my session pulled up over here. Got Zernal. Zernal is the note-taking app that I use. We're just starting a new segment, which is section 4, paragraph or article number 104. So let's go ahead and get into it, okay? Got the page laid up over here. We'll go ahead and label this as the Elements of Arithmetic. Elements of Arithmetic. Section 5, and this is page number 1. Okay? So we're good. We are ready to go. Let's begin. Section 5, and the title here is Fractions. Fractions. I wonder why. I wonder why it keeps on bugging out. That's not very nice. We're back again. If it keeps on doing it, I need to check and see if maybe there's a process running in the background. Okay. Article 104. Suppose it required to divide 49 yards yards. Okay, yard is interesting. I don't know if I've done yard before. Let's go ahead and check it. Ah, okay. Into 5 equal parts. Equal. There we go. Or, as it is called, to find the 5th part of 49 yards. Fifth. For this, I'm just going to do F and then TH underneath. Okay. If we divide 45 by 5, the quotient is 9. And the remainder is 4. That is, according to Article 72, (49) is made up of 5 times 9 and 4. I'll do the English here, but we could write this algebraic or using the arithmetic symbols as well, which would be 5, the times symbol, 9, and then the 4. And then we're going to show this using a geometric perspective, okay? So we're going to let line, line, check that quickly. Ah, that uses an A. There we go. Let the line. Also, let me check let. Is that a T? Nope, just an E. And this is AB, so the line AB represent 49 yards. And represent is, that's repeat. Is that also represent, or is it RPR? Just RP. So if we have our line length and we're showing it here, we would have A over here. Let's do a straight line. Okay. Then we have B. Oh. Right here. Okay. And then take 5 lengths, C, D, E, F, and G. So let's go ahead and lay those out below. C, D, E, F, and G. All right, and we'll go ahead and create line lengths here about that long, and I'm just going to copy that line segment, put that here, then I'm going to copy both of these, put that down below, and there we go. So I have 5 equal line lengths, and each of those is equal to 9 yards. So let's go ahead and label some stuff here. This is going to be equal to 49 yards. Okay, each of these is equal to 9 yards. Okay, the line H is 4 yards in length. The line H is 4 yards in length. Okay, so let's go ahead and do one more here. This is H. Okay, grab another line segment, and we're going to call this one 4 yards. All right. So we have pretty much everything laid out as it is. J, K, L, M, and N are listed with each of the other line segments, and then H, I, J, K. All right. And technically speaking, you know, I probably could just skip all that because, like I said before, the purpose of the stream is to demonstrate the copywork of Gregg more than the actual mathematics. The mathematics is the basic material, but the real area of interest is Gregg Shorthand. So I'll probably not write the rest of the example, and we'll just have it there as the PDF to use as reference. Okay, so we'll do a line below, move it down. We take 5 lines, and this is C, D, E, F, and G. Each 9 yards in length. And the line H four yards in length. Then, since 49 is 5 times, or is 5 nines, is 5 nines and 4 C. Let's do another line below. C, D, E, F, G, and H are together equal to AB. Divide H, which is 4 yards, into 5 equal parts. I, K, L, M, and N. And place one of these parts opposite to each of the lines, C, D, E, F, and G. It follows that the 10 lines C, D, E, F, G, H, I, J, K, L, M, N, C, D, E, are together equal to AB. Or 49 yards. Now D and K together are of the same length as C and I together. And so are E and L. F and M, and G and N. Therefore, C and I together repeated 5 times will be 49 yards. That is, C and I together make up the 5th part of 49 yards. There we go, and that's all of Article 104. Have to read back over it. That's part of the Gregg. The Gregg experience is, once again, this is a Copywork and reading stream, and it's for the purpose of learning Gregg Anniversary shorthand for dictation purposes, for note-taking purposes. So therefore, boring as all get out, but you go back and you reread it so that your mind has a chance to actually learn and become informed by by exposure to the form. Okay, so here we go. This is Article 104. Suppose it, suppose it's required to divide 49 yards into five equal parts, or as it is called, to find the 5th part of 49 yards. If we divide 45 by 5 and the quotient is what is that? Is 9. Oh, duh. I'm looking at this right here and thinking, what sort of Gregg word is that? It's the number 9. All right, so the quotient is 9, and the remainder is 4. That is, according to Article 72, 49 is made up of 5 times 9 and 4. Another way to say this, just to put it in context, this would be the times symbol, and this is the plus symbol, right? So 49 is equal, in fact, we could say that 49 is equal to 5 times 9 plus 4, okay? Another way to look at the same situation, all right? carrying on. Let the line AB AB represent 49 yards. And then we have this laid out here, A to B, 49 yards, and then these are the segments of 9 yards, and then H is a segment of 4 yards, okay? Now, I'm going to zoom over here so you can see this is the representation that they're using. This is the diagram that De Morgan is using to describe the process that he then lays out here in plain text, or in Gregg text. It's not really plain text, is it? So, go ahead and get started here and begin the reading. Take 5 lines, C, D, E, F, and G, each 9 yards in length, and the line H 4 yards in length. Then, since 49 is 5 nines and 4, for C, D, E, F, G, and H are together equal to AB. Divide H, which is 4 yards, into 5 equal parts, I, K, L, M, and N. And place one of these parts opposite. I'm pretty sure that's opposite, but I have to check. Every once in a while, my brain decides to go on vacation, even though it should be working. And yes, that is correct. That is correct. Let's make the S just a little bit more pronounced. But other than that, we are dealing with opposite. All right? Like so. Opposite to each of the lines, C, D, E, F, and G. It follows that the 10 lines C, D, E, F, G, H, K, L, M, and N are together equal to AB, or 49 yards. Now, D, and so notice now he's talking D and K, right? So it's the long segment and short segment. D and K together are of the same length as C and I. Hold on. Shouldn't that be C and J? Ooh, hold on. Did they miswrite something? Oh, that's an I. That's an I. I was misreading the diagram. I thought that was a J there for a second. Okay, well, we'll not worry about it now. So it's the same length as C and I together. And so are E and L. Let's make that R just a little bit less grandiose. Okay. So are E and L, F and M, and G and N. Therefore, C and I together, repeated 5 times, will be 49 yards. That is, C and I together let's make that M just a little longer. All right, make up. Yep, that's up. They make up the 5th part of 49 yards. All right, now moving on to the next article. 105. Here we go. C is a certain number of yards. C vis-a-vis, and that's vis-a-vis 9. But I is a new sort of quantity. So C is a certain number of yards, vis-a-vis 9. But I is a new sort of quantity. To which hitherto we have never come. That's cute. Let's look up hitherto. There it is. All right. Yeah, that's it. That's it. Make the TH just a little smaller. We have never come. It is not an exact number of yards. For it arises from dividing 4 yards into 5 parts. And taking one of those parts. It is the 5th part of 4 yards. And is called a fraction of a yard. It is written thus. As a 4/4 part of 5, right? Or the 5th part, or what was it? 5th part of, was that? 5th part of 4 yards? Dividing 4 yards into 5 parts. That's it, yeah, so it would be 4/5. 4/5, okay? Let's see. Probably be able to write that as maybe offset just a little bit. So if I do a 4 here, like that, 4 forward slant, and then a 5, like so, all right? And that is according to article number 23. And is what we must add to 9 yards. In order to make up the 5th part of 49 yards. The same reasoning would apply to dividing 49 bushels of corn. New paragraph, by the way. I'm not going to bother reading until we actually get to our next article. So here we go, new paragraph. The same reasoning would apply to dividing 49 bushels of corn. Let's look up bushels. I believe it's bush, like so. Yep, it is just BSH. And I need to write bushel down to add to the dictionary. Now notice, so in order to show the 49 bushels, you do the number in the top corner and then the BSH below it. So to demonstrate the same thing, we would have 49 up here and then like that, 49 bushels, okay? The same reasoning would apply to dividing 49 bushels of corn. And a bushel is, what is the equivalent? Blanking on it right now. Let me go ahead and check this, what a bushel is. It is a unit of measurement for grain and for quantity. It's an imperial and U.S. customary unit of volume based on an earlier measure of dry capacity. And what does it equate to? Dry volume, it's equal to 32 quarts, okay, or about 35.2 liters. 4 pecks, 32 quarts, or 35.2 liters, okay? While legally a measure of volume, modern commodity markets generally use standard weight equivalents depending on the crop, okay? So let's go ahead and write that out here quickly, just so that we're kind of on the same page or we know what he's talking about. A bushel, a legal bushel, which is what he's speaking of here. Let's just make a note here. Okay, one bushel is equal to 4 pecks, also another old term. I mean, who talks about pecks now, other than if you're working out at the gym? But a peck was a fourth part. A peck was a fourth part of a bushel. So we'll write that out here. It is equal to 4 pecks, okay, which is equal to 32 quarts, 32 quarts. And a quart is going to be, I think it's just Q, it's KT. Let's check that out. No, it requires a U or an O hook, like so. So it's 32 quarts, which is then approximately, or which is then actually equal, I think. I think it's a strict equality, or about 35.2 liters, okay? So let's go ahead and go back over here to Gregg, which is approximately 35 and 35.2. liters, and a liter, we're going to do liter, like so. All right, so that just helps us out a little bit. So 1 bushel is equal, and let's change that because that looks like a fraction. So 1 bushel is equal to 4 pecks, which is equal to 32 quarts, which is approximately equal to 35.2 liters. Now it is interesting, in Gregg's shorthand, what you would do is you would write the number and then you would write the unit below. Okay, so that's 1 bushel equal to 4 pecks, 32 quarts, like so, which is approximately equal, use the approximation symbol, which is approximately equal to 35.2, and then we would do liters underneath. Okay? Anytime you're dealing with units, that is the approach. All right, so the same reasoning would apply to 49 bushels of corn. So, for instance, that would be, if we have 49 bushels, that would be equal to 49 times 32 quarts. Just to kind of put it in context as far as the size that we're talking about, it would be, if we multiply it out, right, we go 49 times 32, okay? We start first with our units, right? So we do 2 times 49. This is just a little bit of review. Not that we need the review, but we'll go ahead and do it here. It will be 18 plus 1. 2 times 4 is 8, plus 1 is going to be 9, so it's 98. And then we throw a 0 in here, right? And then we do 3 times 9 is going to be 27, and then 3 times 4 is 12, plus 2 is 14, okay? And then we add that value up and drop down our units, add our tens, we get 16, add 1 unit to 4 to give us 5, and then we have 1. So 49 bushels of corn is going to be equal. Now that could be also corn grain, so it would be wheat or anything, any grain is going to be equal to 1,568 quarts. And do a quart unit would be like that. Okay, so that's essentially our value. I'm going to erase that, but that's the amount that he's talking about. 1,568 quarts of grain or of corn. All right, let's move on. The same reasoning would apply to dividing 49 bushels of corn, or the same thing, 49 acres of land. Now an acre, so same thing here. If we're talking about units, then in Gregg we would put the symbol underneath. Okay, 49 acres of land. There we go. Into 5 equal parts. We should find for the 5th part of the first. Nine bushels and the 5th part of 4 bushels. And for the second, 9 acres and the 5th part of 4 acres. We say then, once for all, new paragraph by the way, we say then, comma, once for all, comma, that the fifth part of 49 is 9 4/5. Or 9 plus 4/5. And that's the idea of the and, right? The and is, or the little addition symbol, is the arithmetic shorthand for the word and. Nine plus 4/5, which is usually written without the addition symbol, but it's understood. Or if we use signs. Oh, interesting. Or if we use signs. I don't know exactly what he means by that, because technically speaking, we've already been using signs. But, hey, he wrote the book, so he can say what he wants. Oh, and what happened there? Oh, I need to add that. That's what it is. I need to add another page. Elements of Arithmetic. Section 5, page number 3. Alrighty. Yeah, 9/9 4/5. Or if we use signs. If we, oh, yeah, and we use is the fun, it's the butterfly. There we go. If we use signs, (49) over 5 is equal to 9 over 5. We, of course, would call this the improper fraction and then the proper fraction, okay? Moving on, those are all the examples as far as taking improper fractions and then figuring out what the value would be. So, for instance, what's the 17th part of 1,237? And then what is the 1,974th part of 10,032, so on and so forth. All those examples, we're going to skip that for now. And before I read before I copy 106, I need to go back and read 105. Drop a paragraph marker here, and we jump back in the lineup, going back to paragraph 105. Mark it. Okay, so now we begin. Let's pull back. Here's 105. C is a certain number of yards, vis-a-vis 9. But I is a new sort of quantity. Does sort require the slight break between the O hook and the T? Not really. Not really. I mean, you can, it is understood. I mean, it could be sought, but in this instance, you can kind of make it out, whether you put a slight break in it or not, but we can. New sort of quantity, to which hitherto we have never come. It is not an exact number of yards, for it arises from divided from the, or from the what? For it arises from dividing. I forgot the dot. It arises from dividing 4 yards into 5 parts and taking 1. Ooh, let's fix that 1. Otherwise, Sean is going to come and get me. There we go. 1, taking 1 and taking 1 of these parts. It is the 5th part of 4 yards and is called a fraction of a yard. It is written thus: 4/5, which now it's according to 30 or to Article 23, using the fractional bar, right? When we spoke of the different forms of division, and I just realized I deleted that, so let's save it. Keep my hand off the undo button. I'm not to be trusted. 23, and is what we must add to 9 yards in order to make up the 5th part of 49 yards. So for instance, in 49 yards, I'm not going to go back and change it, but same thing. If we're dealing with units, then we put the number up top and we would write the unit below. Okay? Next paragraph. The same reasoning would apply to dividing 49 bushels of corn, which, just for reference, 1 bushel is equal to 4 pecks, which is equal to 32 quarts, which is equal to 35.2 liters, okay? Or 49 acres of land into 5 equal parts. We should find for the 5th part of the first 9 bushels and the 5th part of 4 bushels, and for the second 9 acres and the 5th part of 4 acres. So if that were rewritten, it would be, we say then, once for all, that the 5th part of 49 is 9 and 4/5, or 9 plus 4/5, which is usually written 9 and then no break between the whole number and the fraction, 9 and 4/5, or if we use signs, 49/5 is equal to 9 and 4/5. All right? Good, good. Moving on. Article 106. By the term fraction is understood a part of any number. Or the sum of any of the equal parts. into which a number is divided. Thus, 49 over 5, let's make it a little smaller, 49 over 5, or 4 over 5, or 20 over 7 are fractions. So all of these are fractions. The term fraction even includes whole numbers. For example, 17 is 7 over, or 17 is, which means it can be written as a fraction of 17 over 1 part, right? 17 divided into 1 part. 34 over 2, 51 over 3, etc. All right. And there we go. So you see, that's how we can rewrite any number. Any number can be written as a fraction, okay? Of course, he's going to talk about 0. I'm sure he's going to talk about 0, which cannot be written. You cannot take the 0th part of something, but we'll wait for him to get there. In the meantime, let's go ahead and read through. The upper number is called the numerator. Okay. Now, numerator. I'm going to assume that numerator is just number, num, and then a disjoint r. But let's go ahead and check that. I was wrong. It's the full value. So we have to go numerate, and then okay? There we go. The upper number is called the numerator. The lower number is called the denominator. Now let me check denominator. Let's see what that is. And there's denominator. So we'll go ahead and do that. dm stroke up over here, and then it uses the backwards r for denominator. Okay? Done. And both of these are called terms of the fraction. As long as the numerator is less than the denominator. Oh, as long as, that's one of our phrases, remember? As long as. Beautiful little phrase. L in, or the L and then in G stroke, and then S for as long as. The numerator is less than the denominator. Mm. The fraction is less than a unit. Thus, 6/17 is less than a unit. For 6 divided into 6 parts, gives 1 for each part. And must give less when divided into 17 parts. Similarly, so we know similar, and then does similarly, haven't had to use that one too much recently. There's similar, similarity, so similarly, oh, interesting, we don't have that. Similarly is just going to add an E to the end, okay? That's a little bit too grandiose, though. That's almost 3 long. We only need it to be 2. There we go. Similarly, the fraction is equal to a unit. Ah. When the numerator and denominator are equal. I'm losing it on numerator. What was this? It wasn't it. Numerator, correct? Did it have an extra E? Nope, that's correct. The numerator, the fraction is equal to a unit when the numerator and denominator are equal. And greater than a unit when the numerator is greater than the denominator. And that's the end of 106. So let's go ahead and read back through. Where is the previous paragraph marker? It wasn't on the previous page. There it is, 105. We had already done 105, so we need 106, which is right here. Good. Let's start. But the terms, or by the terms? By the terms, yeah. By the term, fraction is understood the part of any, let's make that E just a little bit more pronounced. There we go. The part of any number other, or, oh, that's an R. Gotta dip that down just a little more. Or the, yeah. Or the sum of any of the equal parts into which a number is divided. Thus, 49 over 5, 4 over 5, and 20 over 7 are fractions. The term fraction even includes whole numbers. For example, 17 is 17 over 1, 34 over 2, 51 over 3, etc. Next paragraph. The upper, let me check upper. Yep. The upper number is called the numerator. The lower number is called the denominator. And both of these are called terms of the fraction, as long as, let's make that S just a little bit more pronounced. There we go. As long as the numerator is less than the denominator, the fraction is less than a unit. Thus, 6 over 17 is less than a unit. For what? For 6. There we go. For 6 divided into 6 parts gives 1 for each part, and must give less when divided into 17 parts. Similarly, the fraction is equal to a unit when the numerator and denominator are equal, and greater than a unit when the numerator is greater than the denominator. Okay? And that was all of 106. Now we're going to do 107, which is, how long is 107? About half a page long. Okay, be right back. Alrighty, here we go. So now we're going to continue with article number, let's take a look here. We're on article number 107. Okay. Let us begin. drop a paragraph marker, highlight it this time, and we start 107. By 2/3, it is meant the third part of 2. By 2/3 is meant the third part of 2. This is the same as twice the third part of 1. The same as twice. This is the same as twice the third part of 1. To prove this, let AB be 2 yards. And divide each of the yards AC CB and CB into 3 equal parts. As listed in the diagram. Okay, so A, D, E, C, E, G, and B. Then, because, so we're going to go ahead and just not worry about that for the moment, but just know that that's the diagram that he's speaking of. Then, because A, E, E, F, so then, because A, E, E, F, and F, B are all equal to one another, AE is the third part of 2. It is therefore 2/3, or 2/3. The third part of 2. But AE is twice AD. and AD is the third part of a yard. Or 1 over 3. The third part of 1 yard. Therefore, the third part of 2 is twice the third part of 1. The third part of 2 is twice the third part of 1. That is, in order to get the length, the third part of 2, or 2 over 3, to get the length, to get the third part of 2, it makes no difference. Whether we divide 2 yards at once into 3 parts, and take one of them, or whether we divide 1 yard into 3 parts and take 2 of them. By the same reasoning, five eighths may be found either by dividing 5 into 8 parts, and taking one of them, or dividing 1 into 8 parts. and taking 5 of them. In future of these two meanings, I shall use that which is most convenient at the time. I, and then isn't shall just an sh? So I shall. I shall use that which is most convenient at the time, as it is proved that they are the same thing. As it is another phrase. This principle is the same as the following. Principle. The third part of any number may be obtained by adding together the thirds of all the units. Of which it consists. Thus, the third part of 2, or of 2 units, is made by taking 1/3 out of each of the units. That is, then it lays it out here. 2/3 is the equivalent to 1/3 times 2. This meaning appears ambiguous. Ambiguous. Isn't it ambiguous? I think it's ambiguous. AMBG. When the numerator is greater than the denominator. Thus, 15/7 would mean that 1 is to be divided into 7 parts, and 15 of them are to be taken. We should here let as many units be each divided into 7 parts, as will give more than 15. of those parts. And take 15 of them. Okay, let's go ahead and read back over 107. Here we go. Another nice side benefit of having to read the text back is gives my hand a chance to recover a little bit. Here we go. 107. By 2/3 is meant the third part of 2. This is the same as twice the third part of 1. To prove this, let AB be 2 yards and divide of the yard and divide of the yard? Is that what it is? Each of the yards. Each of the yards, that's what I forgot. And divide, oh, there you go. And divide each of the yards. AC, yes, AC and CB into 3 equal parts. Then, because AE, EF, and FB are all equal to one another, AE is the third part of 2. It is therefore 2/3, but AE is twice AD, and AD is the third part of a yard, or 1/3. Therefore, 2/3 is twice the what is therefore twice 1/3. I wonder what that symbol was right there. That's incorrect. Is twice 1/3. Yeah, it's twice 1/3. That is, in order to give the length 2/3, it makes no difference whether we divide 2 yards at once into 3 parts and take one of them, so that needs to be longer. There we go. One of them, or whether we divide 1 yard into 3 parts and take 2 of them. But by the same reasoning, 5/8 may be found either by dividing 5 into 8 parts and taking 1 of them, or dividing 1 into 8 parts and taking 5 of them. In future of these 2 meanings, I shall use that which is most convenient at the time, as it is proved that they are the same thing. This principle is the same as the following. The third part of any number may be obtained by adding together. So that's had. There we go. by adding together the thirds of all the units, of which it necessitates, is that, no, of consists. It consists, let's make that just a little bit more clean. There we go. It consists, of which it consists. Thus, the third part of 2 or of 2 units is made by taking 1/3 out of, or 1/3 out of each of the units. That is, 2/3 or 2/3 is equal to 1/3 of the 2 units. 1/3 of the 2 units. This meaning appears ambiguous when the numerator is greater than the denominator. Thus, 51/7 would mean that it is. Oh, hold on. It was 2. Would mean that. What is that? That 1. Oh, that's the numeral 1. I'm sitting there like, the S is on the wrong side. What's going on here? All right. That 1 is to be divided into 7 parts, and 15 of them are to be taken. We should here let 9 mean, or we should here let as many. We should here let as many units be each divided into 7 parts, as well as will give more than 15 of those parts, and take 15 of them. All right, so that was 108. So I grab a little bit of water, so I'm parched, and then we continue. Alrighty. So let's proceed. The value of a fraction. So here we go. This is article number 18, or article number 108. The value of a fraction is not altered. By multiplying the numerator and denominator by the same quantity. Take the fraction 3/4. Multiply its numerator and denominator by 5. and it becomes 15 over 20. Which is the same thing as 3 over 4. That is, 1/20th part of 15 yards is the same thing as 1/4 of 3 yards. Or if our second meaning of the word fraction be used, you get the same length by dividing a yard into 20 parts, and taking 15 of them, as you get by dividing it into 4 parts. And taking 3 of them. To prove this, and then we have a little example here. Let AB represent a yard, I need to check represent one more time. Correct. Divided into 4 equal parts. AC, CD, DE. And EB. And divide each of these parts into 5 equal parts. Then AE is 3/4. Oh, I lost connection, it looks like. Back out it. Huh. Let's see. Well, that's interesting. Twitch is working, but YouTube is not. Dun, dun, dun. Or, oh, it's on now. Interesting, interesting. I lost disk, I lost connectivity there for a second. Okay. Let's continue. Let's continue. Ouch. Oh, my foot fell asleep. Ouch. Ow. Ow. Oi. Okay. All right. Where was I? So we have let's go back over here. Then AE is 3/4. Then AE is 3/4. But the second division cuts the line into 20 equal parts. Of which AE contains 15. It is therefore 15/20, or 15/20ths. Do that in one go. Therefore, 15/20 and 3/4 are the same thing. Again, since 3/4 is made from 15/20, by dividing both the numerator and denominator. By 5, the value of a fraction is not altered by dividing. Both its numerator and denominator by the same quantity. This principle is of so much importance in every part of arithmetic. This principle, which is of so much importance, which is of so much importance in every part of arithmetic, is often used in common language. As when we say that 14 out of 21 is 2 out of 3, etc. And that's it on 108. So now we go back and we reread 108. The value of a fraction is not used, is not uttered, is not altered, is not altered by multiplying the numerator and denominator by the same quantity. Take the fraction 3/4 or 3/4. Multiply its numerator and denominator by 5, and it becomes 15/20, which is the same thing as 3/4. That is 1/20th part of 15 yards is the same thing as 1/4 of 3 yards. Or if our second meaning of the word fraction be used, you get the same length by dividing a yard into 20 parts and taking 15 of them, as you get by dividing 1 into 4, by dividing it into 4 parts and taking 3 of them. To prove this, let AB, and for this we'll use our little line segment, let AB represent a yard. Divide it into 4 equal parts, AC, AC, CD, DE, and EB. And divide each of these parts into, straighten up this part here a little bit. The T shouldn't come down quite that far. There we go. These parts into 5 equal parts. Then AE is 3/4, but the second division cuts the line into 20 equal parts, of which AE contains 15. It is therefore 15/20ths. 15, or the 20th would be 15 out of 20 parts. Therefore, 15/20ths and 3/4 are the same thing. Again, since 3/4 is made from 15/20ths, by dividing both the numerator and denominator by 5, the value of a fraction is not altered by dividing both its numerator and denominator by the same quantity. This principle, which is of so much importance in every part of arithmetic, is often used in common language, as when you say, or we say, that 14 out of 21 is 2 out of 3, etc. 109. Though the fractions 3/4 and 15/20ths are the same in value, and either of them may be used. For the other without error, check error. Isn't it ERR? Yes. Yet the first is more convenient than the second. Not only because you have a clearer idea of the fourth, of 3 yards, then the 20th part of 15 yards, but because the numbers in the first, being smaller, are more convenient for multiplication and division. It is therefore useful when a fraction is given to find out whether its numerator and denominator have any common divisors or common measures. In Article 98 was given a rule for finding the greatest common measure. And it was shown that when the two numbers are divided, by their greatest common measure, the quotients have no common measure except 1. Find the greatest common measure of the terms of the fraction and divide them by that number. The fraction is then said to be reduced to its lowest terms. What is lowest? Check it. There we go. reduced to its lowest terms. Let me go ahead and check that. I need to check reduced. That's correct. Good. Reduced to its lowest terms, and is in the state in which the best notion can be formed of its magnitude. And is in the best state in which, and is in the state, and is in the state when the best notion can be formed of its magnitude. Formed. Does it require a sharp turn in the D or? Nope, it's disjoined. Can be formed of its magnitude. Magnitude is that magnitude? Check magnitude. Oh, yes, that's right. And then we have all these exercises here. With each of the fractions is written the same, reduced in its lowest terms. So then you would practice finding all those values. We're not going to worry about that right now, but I am going to go ahead and read back over the paragraph before going on to Article 110. Let's go ahead and drop that here. And then we go back and read Article 109. (108). Where's 109? 109 starts with though the fraction's 3/4. There it is. Good. 109. Though the fractions 3/4 and 15/20 are the same in value, and either of them may be used for the other without error, yet the first the first is more convenient than the second. Not only because you have a greater idea of the fourth of 3 yards than the 20th part of 15 yards, but because the number is in the first being smaller, are more, the numbers being smaller, are more convenient of multiplication and division. It is therefore useful when a fraction is given to find out whether its numerator and denominator have any common divisors or common measures. In 98, also, in 98, Yeah, in 98 was given a rule for finding the greatest common measure of any two numbers. And it was shown that when the two numbers are divided by the greatest common measure, the quotients have no common measure, except they have no common measure except 1. Find the greatest common measure of the terms of the fraction and divide them by that number. The fraction is then said to be reduced to its lowest terms, and is in the state when the best notion. Let me check notion. Yep. When the best notion can be formed of its magnitude. Moving on to Article 110. When the terms of the fraction given are already in factors, any one factor in the numerator may be divided by a number provided some one factor in the denominator is divided by the same. This follows from Articles 88 and 108. In the following examples, the figures altered by division are accented. Then accented. What is accented? Huh, I don't think I've ever done accented before. There we go. Accented. Okay. We're going to skip the examples, but they're accented, meaning the, what is it? They said the division examples, the figures altered by division are accented. So it simply means that we remove them, okay? A factor of a number is a number which divides it without remainder. Thus, 4, 6, 8 are factors of 24, and 4 times 4, 8 times 3, 2 times 2, 2 times 2 times 3 are several ways of decomposing 24 into factors. That's the idea, is the decomposition of a number into its factors. It's actually, in some ways, it's the best way to look at a number. You get a real sense for what the number is, okay? So that was all of 1010. So let's go ahead and read back over that. Okay, here we go. Article 110. When the terms of the fraction given are, when the terms of the fractions given, or just fraction? Yep. The fraction given are already in factors. Any one factor in the numerator may be divided by a number, provided some one factor in the denominator is divided by the same. This follows from Article 88 and Article 108. In the following examples, the figures altered by division are accented, and that was here. Okay, so those are the accents that he's speaking of. I'm going to skip past that. Let's go to Article 111. Okay. As we can by Article 108, multiply the numerator and denominator of a fraction. By any number without altering its value. we can now readily reduce two fractions. Two fractions to two others, comma, which shall have the same value as the first two, which shall and which shall have the same denominator. Page below. Take, for example, 2/3 and 4/7. Multiply both terms of 2/3 by 7. And both terms of 4/7 by 3. It then appears that two-thirds is, and then we can lay this out here, two-thirds is 2 times 7 over 3 times 7, or 14/21. or the 14 21st parts. And then 4 over 7 is 4 times 3 over 7 times 3, or 12 21sts. Here are the two fractions, 14 21sts and 12 21sts. (14 over 21) and 12 over 21 equal to 2/3 and 4/7. And having the same denominator. (21) in this case, 2/3 and 4/7 are said to be reduced to a common denominator. And we start with reduced, we underline all this, reduced to a common denominator. It is required to reduce 1/10, 5/6, and 7/9 to a common denominator. In other words, that's our problem that we're facing. Multiply both terms of the first by the product of 6 and 9. Of the second by the product of 10 and 9. and of the third by the product of 10 and 6. Then it appears according to Article 108, that 1 over 10 is equal to 1 times 6 times 9 times 10 times 6 times 9, which corresponds to 54 540ths. Five over 6 is then the equivalent of 5 times 10 times 9 over 6 times 10 times 9, which is then 450 540ths. Common denominator across them all. And then the final one is 7/9, which is then rewritten as 7 times 10 times 6 all over 9 times 10 times 6, which is 400 540ths, or 420 over 540. Okay? On looking at these last two fractions, we see that all the numerators and the common denominators are divisible by 6. Okay. Almost there. Almost there. Here we go. On looking at these last two fractions, on looking at these last two fractions, we see that all the numerators and the common denominators we see that all the numerators and the common denominator are divisible by 6. And this division will not alter their values. on dividing the numerator and denominator, on dividing the numerators and denominators, of 54 over 540ths, 450, 540ths, and 420, (540ths) by 6. The resulting fractions are 9/90ths, or 9 over 90, 75 over 90, and 70 over 90. These are fractions with a common denominator. And which are the same as, and which are, oh, come on, and which are the, and which can actually be one together, are the same as 1/10, or 1 over 10, 5 over 6, and 7 over 9. Whoa, that is a long explanation. Okay. I've got 1 minute left. Let's just keep on going. Keep on going, and be able to call it, be able to have a break here in just a second. Okay. And therefore, these are a more simple answer to the question than the first fractions. And therefore, these are a more simple answer to the question than the first fractions. All right, so there's our time. That's it for now. I'm going to take an hour break, and I will be back at, let's see, it's 12:53 for me right now. So I will be back at 1:53, 1:40, 1:53 thereabouts. So hope everyone's having a good afternoon. just putting in more time. So thank you so much, and I will see you in a little